All right, let's go over number 2. It asks you to write formulas for the compounds formed between the following. Now, it is not what this worksheet is asking you to do, but it might be helpful if you were to identify, because I'll point out that all of these are going to be ions. Every single thing here is going to be an ion. And so it might be helpful for you to start by taking these names and then representing them using their symbols. Okay, so that way you can know the charges. Because if these are ionic compounds, then the overall charge of the compound has to be 0. The only way that you can double check that you've successfully got them to equal 0 is by knowing the charges. So if we start with aluminum and bromide, aluminum is going to be a +3 charge because it's in a main group 3. Bromine, or when it's bromide, I should say, is going to be a -1 because it's in main group 7. It wants to gain 1 electron. Now, if you remember the trick I told you, if we identify the numbers here, not the charges, but the numbers, and then we just cross them, it's going to give us a really easy way to instantly know that I need 3 bromides for every 1 aluminum. Right? Each bromide has a -1 charge. The aluminum has a +3 charge. So in order for them to have an overall charge of 0, we need 3 bromides. Do the same thing for sodium and oxygen. Looking up at sodium, it is in main group 1, so that's a +1 charge. Oxygen coming in main group 6, so it's going to have a -2 charge. Cross those charges. So I have Na2O. Looking at magnesium and iodine, we got Mg coming in main group 2, so +2 charge. Iodide coming in main group 7, so it's going to have a -1 charge. Cross those charges, so I have Mg1I2. All right, now starting with D, they're actually giving you the charges here because a lot of these are transition metals, right? Transition metals, right? They can form that variety of charges, so they kind of got to give them to you. So this is lead 2, so that's got a +2 charge. Oxygen has a -2 charge, so you can see that if you simply have 1 of each of them, the charges will cancel out, and you'll have an overall charge of 0. Let's look at E. You got tin 2 and iodide. Well, I need 2 iodides to balance out the +2 charge from tin. So I'll go SNI2. Go over to F. Now here's where the crossing trick really helps you out. Okay, a lot of people really struggle with this 2 and the 3. Okay, because so far all we've done is have either 1 of each or then just have 2 of one and 1 of the other. It hasn't been that difficult. Right here, the crossing trick really works. I'm going to take this 2, I'm going to put it at the bottom of the Fe. I'm going to take this 3 and put that at the bottom of the sulfide. And end up with Fe2, well, Fe, there's an E there, trust me. Fe2 S3. You know, I'm just going to rewrite that. Fe2 S3. This is iron 3 sulfide. All right, now we're dealing with copper and nitrate. Now, nitrate has a -1 charge. This type of copper has a +2 charge. So I'm going to need 2 nitrates to balance out the copper. But what's the problem with that? The way I've drawn this is 32 oxygens. There's not 2 nitrates. There's 32 oxygens. So, hope you guys got it. I'm going to put this unit this nitrate in parentheses. Just like in math, you have the distributive property of multiplication. Distribute that to some quantity that is in a parentheses. That same idea is going to come into play here when you put these polyatomic ions into parentheses. That 2, it means there are 2 nitrates, 2 units. So if each nitrate has 3 oxygens, if you have 2 nitrates, you have overall 6 oxygens. You have overall 2 nitrogens. All right, now we're getting some polyatomic ion action over here. We have ammonium and sulfate. Okay, ammonium and sulfate. All right. First thing I see, this has a +1 charge, this is a -2 charge. I'll cross those charges so that I only need 1. Okay, I only need 1 sulfate. But how many ammoniums do I need? I need 2. So again, I need to put that in parentheses so that I can indicate that I need 2 of those units, not 42 hydrogens. And then one sulfate. 1 sulfate. Now, typically speaking, most people aren't going to put this second sulfate into parentheses, but you can. It's not wrong. It's just a little extra step. You don't have to because, again, you're not being confused by some other subscript.